Hey y'all, welcome to 2.2 part A. Today we're going to be factoring polynomials. Remember, polynomials have multiple terms. Their exponents are positive whole numbers or zero. There's no negative exponents, no fractional exponents. The first thing you want to look for when we do any factoring problem is a GCF, which is the greatest common factor. So examine all the terms, look at the variables and the coefficients, and find the greatest value variable and coefficient that can factor out of each term. So if we look at example 1 over here, its greatest common factor for the numbers is going to be 3, but then look at the variables. Every term has at least one power of a, so 3a is that greatest common factor. Then to actually factor that out, we take each term and we divide it by that greatest common 3a, and then what remains is inside the parentheses. So in that first term, the 3 divides out, the a divides out, leaves us with just a b. Plus, in the second term, 9 over 3 is 3. A squared over a is a. And the b stays there because there's nothing to divide it. Then in that last term, 27 divided by 3 is 9. A divided by a divides out. And this is completely factored form. Greatest common factor, divide it all out. Make sure we keep the greatest common factor written down on the outside. Don't forget about it. Okay, the next question we want to ask ourselves after we greatest common factor is how many terms the polynomial has. Polynomials with 2, 3, or 4 terms can be factored more. And we want to discuss the 4-term factoring first. So for the 4-term factoring, we want to group the factors. We will group them into 2 groups of 2, and then we're going to greatest common factor each of those groups. So group into 2 groups of 2, then find the greatest common factor of each of those groups. So looking at example 3, take the first 2 terms as one group, take the last 2 terms as another group. Then look at that first group, 2x to the third plus 8x squared. Factor out 2. The variables, factor out x squared. Okay, when we divide both of those terms, just those 2 terms, by that 2x squared, divide here by 2x squared, divide here by 2x squared, that gives us x plus 4. 2x to the third divided by 2x squared. The 2's divide off, leaving 1 power of x. 8x squared over 2x squared. The x squareds divide off. 8 over 2 is 4. Now, we need to be very careful with this next piece because we do need to bring down the sign here in the middle. So I'm going to bring down that minus. Then look at negative 3x minus 12. That greatest common factor is 3. There's not going to be a variable because there's not a variable on the 12. So divide 3x, negative 3x minus 12. Divide both of those by negative 3. Watch those negatives. And we end up with negative 3x divided by negative 3 is simply x. Negative 12 divided by negative 4. By negative 3 is positive 4. Now, if we notice in these parentheses, the factor in the parentheses matches. That means this factoring worked. So that means that x plus 4 is one of the factors in our problem. The other factor comes from the greatest common factors that we divided out. So this x plus 4 comes from what matched. The 2x squared minus 3 comes from the greatest commons we pulled out of each group. Okay, then this is your final factored form. Now, you could also write this in the other order. You could put the 2x squared minus 3 parentheses first, and you could put the x plus 4 parentheses after it. Both of those are equally correct. Full credit, all of the above. Does not matter which order you put those in. Now, we use this method for factoring 4 terms in order to help us factor things with 3 terms. So let's go back over here to the right and let's go to 3 terms. When we have 3 terms, we are looking at problems in the form ax squared plus bx plus c. Ax squared plus bx plus c. What we want to do is find the magic numbers. It's a really official term, magic numbers. Find the magic numbers. The magic numbers need to have a product or multiply to equal the a times the c. The a here, the c here. They need to have a sum that adds up to b, that middle term. Then we use those magic numbers to split the middle, as in split the middle term. And I'm going to show you how all that works. Okay, so if we look at example 2, 4x squared minus 4x minus 15, there's no greatest common factor. It has 3 terms, so we're going to look for the magic numbers. Okay, these need a product or a multiply of a4 times c, negative 15. It's going to be negative 16. The magic numbers will need a sum of that middle term, which is negative 4. Now, you may have seen this with an X, with a box, with a list, with all sorts of other visual cues, but it all boils down to finding that set of magic numbers. Okay? Sometimes you'll be able to look at your sum and product and immediately find those numbers. Sometimes you may have to list the factors. If you list the factors, I highly recommend you do them in order, meaning starting with 1. So here, 1 times 60, 2 is a factor, times 30, 3 is another factor, times 20, 4 is a factor, times 15, 5 times 12 are factors, 6 times 10, it's another factor, 7 is not a factor, neither is 8, neither is 9. So this is our complete list of factors. Now, we need these to multiply to equal actually negative 60. So we need a negative sign on them. We also need them to add up to negative 4. So the larger number needs that negative sign. The smaller number is positive. If you will list the factors in order, these positives and negatives turn out to be pretty straightforward. Okay, looking at this list, positive 6 and negative 10 are our magic numbers that multiply to negative 60 and add up to negative 4. So those are the magic numbers we're going to use. Now, what we do with those magic numbers is split up the middle term. That middle term was negative 4x. I'm going to convert that negative 4x to plus 6x minus 10x using the magic numbers we just found and the variable that's on the middle term in the problem. There's still a 4x squared as the first term. There's still a minus 15 as the last term. So all we did here was split that middle term. Now, we split this up for a reason. Now there's 4 terms. So we use that 4-term group and greatest common method in order to factor this from here. So we'll group the first 2 terms. We'll group the last 2 terms. Grouping the first 2 terms, look at its greatest common factor. 4 and 6 have a common factor of 2. The x squared and x, there's at least 1 power of x in each of those terms. So then we divide. 4x squared divided by 2x is 2x. 6x divided by 2x is plus 3. The x divides out there. Okay, now don't forget we bring down this sign in the middle, so we bring down this minus. Looking at 10x minus 15, negative 10x minus 15, that greatest common factor is 5. There's not going to be a variable there. When we divide negative 10x by negative 5, we get 2x. When we divide negative 15 by negative 5, we get plus 3. So this factoring worked because the values in the parentheses matched. As long as there are magic numbers that really do give you the correct sum and product, when you split and group and GCF, you should get the same thing in each parentheses. If you don't, there's an error somewhere, go back and check your work. So that 2x plus 3 is one of the factors. The other factor would be the 2x minus 5. And this is factored form. Again, you can write the parentheses in the other order if you'd like. This is factored form. Okay. Find the product and the sum, find the magic numbers, split the middle term with the magic numbers, then group and greatest common. Now, that's the method for 3-term factoring. There's one other type of factoring that works, and that is when we have 2 terms. And when 2 terms, we have to ask ourselves an additional question. With those 2 terms, do they contain only perfect squares or only perfect cubes? And if they do contain squares or cubes, then we can factor it further. So let's look at squares first. If both of the 2 terms are perfect squares, we can factor using a method called difference of squares. Difference meaning subtract. So only if the 2 squared terms are subtracted can we factor it. We can't factor it squares if there's a sum. So we want to think of this almost like it's a formula. We have something squared minus something else squared. In this case, it's real straightforward. It's x squared minus y squared. So when we factor it, it factors into 2 parentheses. One of them's added, one of them is subtracted. Each parentheses has 2 terms. We take this x, we took the square root. We took the square root of this first term to get this x. X goes at the first spot in each parentheses. We took the square root of y squared to get that y, and it's that y that goes in the second spot in each parentheses. This is your factored form. So x squared minus y squared factors as x plus y times x minus y. Try not to make this one too hard. Take the square root of each term, add those in one parentheses, subtract those in the other parentheses. So let's look at an example. Example 4, there's not a greatest common factor. There are 2 terms. They are perfect squares, and they are being subtracted. So we need to figure out the square root of each of those terms, or figure out what squared gave us each term. So 4x squared, take its square root, that's 2x. We have to square 2 to get 4, square x to get x squared. Then on the 9, we square 3 to get the 9, or square root of 9 is 3. So we take those 2 terms, we add them in one parentheses, we subtract them in the other. So 2x will be first in each parentheses, 3 will be next in each parentheses, and this factors as 2x plus 3 times 2x minus 3. Take the square root of each term, add them in one parentheses, subtract them in the other parentheses. Now, you do want to check each of these and make sure there's not another difference of squares. And in this case, neither one of those factored terms have squares, so we're safe. Now, cubes are a little different. Cubes are a little different. For the cubes, we can factor the sum or the difference of cubes. So we can add and subtract cubes and still factor them. With squares, we can only subtract in order to factor. Okay, so we have the same idea again. We have something to the third, either plus or minus something else to the third. And in this case, real straightforward, x and y. Now, in this factors, okay, the first parentheses has 2 terms. The sign in that first parentheses is the same sign as the original problem. So the top row has x squared, x cubed plus y cubed. So this first sign is positive. The bottom row has x cubed minus y cubed. So that's going to be a subtraction. Okay. Then the second parentheses has 3 terms. The first of those signs is opposite from the original problem. And the very last sign is always positive. Now, there's a way to remember the signs. And I know all we have in here is the signs, but there's a cute little way we can remember the signs for those cubes. The first one is the same as in the original problem. The second sign is opposite from what's in the original problem. The last one is always, there's an S there we go, always positive. And if we look at the letters, S-O-A-P, that is SOAP. So SOAP is an acronym that can help you remember the signs. First sign is the same as in the original problem. Second sign is opposite. Last sign is always positive. Now, the other way this works is that the first parentheses has each term to the first power, each value to the first power. So x and y go in the first parentheses. In the second parentheses, everything is to the second degree, second power. So it's x squared, then it's x times y, and then the last term is y squared. Notice all of those are double powers, either second powers or 1 power of each variable, so double powered. Okay, think of these as the formulas for factoring cubes. We need to find the x, we need to find the y, and then plug into the formula. So looking at example 5, there's not a greatest common factor. It's 2 terms, and both of those terms are perfect cubes. We have something cubed minus something cubed. That first term, x cubed, we just cube x. That second term, 125, we cube 5. 5 times 5 times 5 is what gives us 125. So in order to factor that, we're using the subtraction. So we're using this formula on the bottom. First parentheses has the same sign, subtract. Second parentheses starts with the opposite sign plus, ends with an always positive. Then we plug in. The first parentheses starts with the x and the y. So that's going to be an x and a 5. X minus 5 is that first parentheses. The second parentheses, we'll take the x, we square it. Then we take that x and we multiply it by the y. Our y is a 5. This y gets replaced with a 5. And then we take that y, again 5, and we square it. We plugged in to the factoring formula. Now, as we keep going with this, we do need to clean this up and simplify it a little bit. That first parentheses is fine, x minus 5. Second parentheses, clean it up a little bit, x squared plus, we usually write this as 5x, then plus 5 squared is 25. So this is the form we want to use as our final answer. Okay, if we look at that first parentheses, it won't factor any further. The second parentheses will not factor any further, ever, as long as you took out a greatest common factor first, if there was one. So that greatest common factor, taking it out at first, is very key here. Now, let's look at some examples when the factoring method's not printed right above it. Let's look at example 6. First thing we always want to look for is a greatest common factor. This has a greatest common factor of 2x to the third. So we'll factor out a 2x to the third. We'll divide each term by 2x to the third. So dividing by 2x to the third. That first term, the 2's divide off. X to the fourth divided by x to the third is just x, minus 4 divided by 2 is 2. X to the thirds divide off. Okay, neither one of those terms will factor any further. So this is as far as we can go. Okay, a quick word about what I just mentioned, and that is factoring completely. Factoring completely means you factor it, then look at each individual factor and see if it can be factored more. And if it can be, you need to factor it more. We're going to see a couple of those on this page. Okay, so let's look at example 7. First thing we always look for is a greatest common factor, and this has a greatest common factor of 2. There's no variable part to that greatest common, just the coefficient 2. So divide every term by 2. That gives us 2x squared plus 7x plus 5. Now, that is factored, but we need to verify if it's factored completely or not. So what we want to do is look at what's in the parentheses. It's 3 terms. 3 terms factor with magic numbers. We need to see if there is a product and a sum that we can find, magic numbers, and see if this will factor some more. The product, use just what's in the parentheses. 2 times 5 has a product of 10, has a sum of that middle term 7. So factors of 10 would be 1 and 10, or 2 and 5. Everything's positive in the problem, so everything will be positive in the factors. And looky here, we do get a set of magic numbers that works. 2 and 5 multiply to 10 and add up to 7. So we take this middle term and we split it into plus 2x plus 5x. The 2x squared stays in front of it. The plus 5 stays on the end. And that greatest common factor of 2 is still hanging out on the outside. Now, there are 4 terms here, so we want to group this. Take the first 2 terms in a group, take the second 2 terms in a group. The 2 greatest common factor still hanging out on the outside. Don't forget about him. Look at the first group, 2x squared plus 2x. That greatest common factor is 2x. Divide that out, and we get x plus 2x over 2x is 1. We need that 1 there. Don't leave it blank. 2x divided by 2x is 1. Then taking a look at that second group, 5x plus 5, the greatest common is 5. So divide 5 out of each of those terms, and you get x plus 1. Now, we wanted these parentheses to match, and they do. If there are magic numbers that truly work, then the problem will factor and these parentheses will match. So we have x plus 1 as one of our factors. We have the greatest commons, 2x plus 5 put together as one of our factors. And we have 2 out front of it all. Don't forget about that 2. Here's your completely factored form. So we started with just a greatest common factor. And then we had a trinomial, 3 terms that would factor more. So we found the magic numbers, and we split that middle term and went from there. Now, let's look at number 8. First thing we want to look for is a greatest common factor. There's not one. All those numbers are even except that 9, so there's not going to be a greatest common there. So we have 4 terms. Method for 4 terms is to group and greatest common. So look at the first group, 2x to the third minus 8x squared, greatest common factor of 2x squared. Divide by 2x squared, we get x minus 8. Then bring down that plus sign between the groups. 9x minus 36 has a greatest common factor of 9. There won't be a variable there. Divide by 9. Divide by 9, we get x minus 4. Okay, and I goofed here, guys. I'm sorry. 8 divided by 2 is 4. So there should be x minus 4 there. Sorry. Forgive me. Now, this divided out nicely, x minus 4. So x minus 4 is one of our factors, and the other is 2x squared plus 9. Now, before we decide if this is a final answer, we need to see if these will factor anymore. X minus 4 is 2 terms, but x is not a perfect square, so it won't work. 2x squared is not a perfect square, and that's a plus, so it won't factor anymore. This is your completely factored answer. Again, you could put the parentheses in the other order, and it would still be just fine. Now, let's look at example 9. We have a look for a greatest common factor, and there's not one. There's 2 terms, so we look to see if these are either squares or cubes. If they are, they'll factor more. If there's 2 terms and they are not either squares or cubes, the problem just won't factor any further. So, look to see these are perfect squares. 4x squared, take its square root, that's 2x. 81a to the 4th, take its square root, that's 9a squared. So as we factor this, we think about that factoring rule from the previous page, and it said that x squared minus y squared factors into x plus y times x minus y. That's the factoring rule from the previous page. So as we factor this, first parentheses will be a plus, second parentheses will be a minus. The x is our 2x, and the y is our 9a squared. Really? Please last long enough to do this video. Okay, now, this is final factored form. 2x is not a perfect square, so this will not factor any further. 9a squared is a perfect square, but it's not going to factor because of the 2x. Now, let's take a look at example 10. Let's take a look at example 10. There's not a greatest common factor. We have 2 terms, so we look to see if they are squares or cubes. And in this case, those powers are divisible by 3. These are cubes. These are cubes, perfect cubes. So, to factor this, we need to find the cube root of each of these. Find the cube root of each of those terms and factor from there. Sorry for that little pause there, guys. Is this not going to let me use it while it charges? Okay, I just learned you can't charge an Apple Pen and use it at the same time. All right, so take this cubed minus whatever this is cubed. That first term, 8a to the 3rd, we take 2a and cube it. For 27, we use 3 cubed. For b to the 6th, that's b squared. Because the power to a power rule is to multiply the exponents. So b squared to the 3rd, multiply those powers, really is b to the power of 6. Now, that factored formula, for factoring these cubes says that x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. That's just the factoring formula from the previous page. Now, The x in our case is going to be the 2a. Plug an x in for everywhere there was an a. 2a, sorry. The y is the 3b squared. So everywhere there was a y, we're going to plug in 3b squared. Okay, so this first parentheses will have the same sign as the original problem. So that will be 2a minus 3b squared. Then the second parentheses, we'll take the 2a and we'll square it. Then plus, we take the 2a and we multiply it by the 3b squared. And then there's another plus. And then we take 3b squared and we square all of it. Now, this is factored, but this is not cleaned up. Okay, so let's work on this a little bit. That first parentheses is good. 2a minus 3b squared. In the second parentheses, we square all of 2a, so that's 4a squared. Plus, we take 2 times 3, we get 6. Variables would be a, b squared. Plus 3b squared squared. We square the 3, we get 9. B squared squared is b to the power of 4. And this is factored. Now, what we did here, I'm going to run through this again. What we did here was we took the cube root of a to the third. That gave us our 2a. That's what we plugged into the factoring formula for x. We took the cube root of 27b to the 6. That's 3b squared. We plugged that 3b squared in place of the y. And that's how we got that factored form. Then we just squared and multiplied and cleaned up what we needed to get that final answer. All right, let's look at example 11. This one looks a lot less crazy. It does not have a greatest common factor, x cubed plus 1. Both of these terms are perfect cubes. So we'll think of this as something to the third plus something to the third. Okay, that first term, x to the third, is simply x to the third. Plus 1 is simply 1 to the third. Now, that factoring rule, that previous page again, says that x cubed plus y cubed equals, parentheses, x plus y, then new parentheses, x squared minus xy plus y squared. That's just the factoring formula from the previous page. So our x is the x, our y is the 1. So this first parentheses is a plus. It's going to have the x first plus 1 as the second term. Then the second parentheses will have a minus and then a plus. That first term will be x squared. That second term will be x times the 1. And that last term will be 1 squared. Plugging in the x for x, plugging in the 1 for y. So when we clean this up, we get x plus 1 times x squared minus x plus 1. Check the two-term factor. If it's perfect squares or cubes, it would factor more. It's not in this case, so we are done here. Okay, we used the cube root of x to the third. That was x. So we kept our x's from the formula as x. Then y to the third was 1, which makes y equal 1. So we plugged a 1 in everywhere that formula had a y. Now, let's look at this last problem. Example 12. First thing we want to look for is if there is a greatest common factor. And there is a greatest common factor of 2. So we're going to factor a 2 out of every term. We get x to the third plus 5x squared minus 9x minus 45. Now, there are 4 terms on the inside, so we look for a greatest common factor in each group. Group in greatest common. So that 2 is still hanging out on the outside. We can't forget about it. Look at that first group. Its greatest common factor will be x squared. Factor that out. X to the third divided by x squared is x. 5x squared divided by x squared is plus 5. Bring down the sign in the middle of the groups. That's a minus. Minus 9x minus 45 has a greatest common factor of 9. Negative 9x divided by negative 9 is x. Negative 45 divided by negative 9 is plus 5. This worked because those parentheses match. So one of our factors is x plus 5. One of our factors is the x squared minus 9. And the other factor is the greatest common factor of 2 out front. Now, we need to look at each factor and decide if it's completely factored. And it's not. It's not quite. I can hear you groan. I know. I'm sorry. It's the way it is. If we look at x plus 5, that's not squares or cubes, but x squared minus 9 is perfect squares. So this will factor a little further. X is what we squared to get x squared. 3 is what we squared to get the 9. So this will factor into 2 parentheses. X plus 3 times x minus 3. We still have the x plus 5 in front of all this, and we still have the 2 as the greatest common factor. So this is completely factored. This is your completely factored form. This line right here is worth a good deal of partial credit, but it's not totally factored. All right, y'all, I know that was a lot crammed into a little bit. That is our factoring lesson. Thanks, y'all.